Now that we've seen how straight lines can be represented by linear equations, i.e. equations in the form of y equals mx plus c, and we have worked with and manipulated those equations, I'd like to introduce another common equation, the quadratic equation, and that's an equation in the form of ax squared plus bx plus c is equal to 0. Now the word quadratic is referring to the fact that we have a power of 2. So ax squared is our quadratic term, bx is our linear term, because linear is referring to the fact that we have a power of 1 here with our x, and c is our constant term. It's not a multiplier of x or any power of x, it's simply just a constant term. So whilst there's a lot more to quadratic equations than I could possibly cover in a single video, I wanted to briefly introduce them, as they do crop up quite a bit in the sort of mathematical problems that we might solve in computer graphics and in programming. So I'm going to show how we can use the knowledge we gained in an earlier video on rearranging equations to rearrange this equation and solve for the possible values of x, and that's something I've personally found to be very useful on many occasions. In actual fact, we're going to need that solution in a later video, but before I do that, I'd just like to briefly introduce to you what a quadratic equation is, what the graphical representation of a quadratic equation might look like, and then we're going to move on to find that solution. So as we saw, as I quickly draw, I guess I can draw this below but leave the equation there, I'm going to draw a very rough set of axes. I'm not going to worry about putting on measurements, I'm just going to label these axes. And as we've seen in our earlier videos, a linear equation, when represented graphically, is a straight line. Well, if we took our quadratic equation here, and instead of making it equal to 0, we put it so that it was equal to y, so we put it in the form of y is equal to ax squared plus bx plus c, that would allow us to represent this graphically on our axes. And when we represent that equation graphically, we're going to get a curve that has a single turning point. So we might get a curve that looks something like this. And you're going to have to excuse my drawing ability, but we'd get a curve that looks something like this, where we have just a single point in which the curve changes direction, and it's going to carry on infinitely going upwards from both of the ends of the curve that I drew. So there's only a single turning point, and we get that one turning point because we have a power of 2 here. So this is a graphical representation of the equation y is equal to ax squared plus bx plus c. But the equation we're trying to solve is ax squared plus bx plus c is equal to 0. So to solve this equation for x, what we're basically saying is we want to find the values for x that will give us a y value of 0, that will give us a 0 here for the part that is equal to ax squared plus bx plus c. So in terms of our graphical representation, when y is equal to 0, that's when we intersect our x-axis. And we can see on our current curve, when y equals 0, i.e. where the curve intersects our x-axis, we have 2 points with different x-coordinates. We have a point here and a point here. Thus the equation for this particular curve would have 2 solutions. Now, a quadratic curve, depending on how we manipulate the 3 parameters of the curve, it can manipulate the shape of the curve in quite dramatic ways. It would manipulate how quickly we accelerate and decelerate into the turning point. It will manipulate the position of the curve in 2D space. We can even flip the curve over so that it is upside down to how we've drawn it here. There's many ways that manipulating these parameters can change the curve, and it's really beyond the scope of this video to explain how those coefficients, how those parameters do manipulate the shape of the curve, but there are a wealth of resources available out there if you are interested in learning about quadratic equations. However, for our purposes, all we really need to know is that if we put in different coefficients, different values for a, b, and C, we're going to define different shaped curves. So a quadratic curve, if it only has a single turning point, the maximum number of solutions is going to be 2. We can only possibly cut the x-axis twice. However, depending on the coefficients of our equation, it's possible that there are less than 2 solutions. For example, if our exact turning point was sitting just on top of the x-axis, something like this maybe, so it just sits on the x-axis, the turning point is going to be a single solution. It's the only point where y is equal to 0. So in that case, we have only one solution. And consider this case. What if our curve was floating completely above the x-axis? We never cut the x-axis. We never have a value where y is equal to 0. There are no solutions for that particular curve. So depending on the coefficients of this equation, there could be a maximum of 2 solutions, there might be just one solution, or there may actually be 0 solutions. This is going to become important later. So let's just recap everything that we've looked at so far before we move on to solving our quadratic equation. So we know that this equation, the equation in the form of ax squared plus bx plus c is equal to 0, is called a quadratic equation. And that if we make that equation equal to y, we're able to graphically represent that equation, and it allows us to determine where our x values are that solve our equation, because it's the values of x where the curve cuts the x-axis. So, in other words, if we were to solve our quadratic equation, we're looking for these values where the line, the curve, cuts the x-axis. So let's actually move on to solving that equation. And in order to solve it, we're going to rearrange this equation to get x in terms of a, b, and c. So I'm actually going to bring up a new whiteboard just so we have the maximum amount of space possible, because this is quite an involved, basically an involved solution to finding x. And it's worth noting that most of these steps are very logical, and they're going to build directly on the knowledge that we've gained in earlier videos. However, one of the steps without an additional mathematical background may seem like it was pulled out of thin air. So when I get to that step, I am going to explain briefly where it comes from, but I'm not going to be covering the theory behind it in detail. It's really beyond the scope of this video. But if you don't understand where it comes from, you will be able to go away and research this using other resources to understand where it comes from. But really, the reason that I'm showing you how we rearrange this quadratic equation is just so that you can see that the formula that we use to solve this equation, the generic formula that will give us the value or values of x, actually comes from somewhere, and that it was derived using techniques that we've already seen, as opposed to just being plucked from thin air. I think it's really important in this case that you do see that it's come from somewhere. It helps to sort of bring everything that we've learnt so far together. So with that, let's start rearranging this equation, and to do so, I'm going to bring up a new layer, and let's start first by writing our equation again. So we have a x squared plus bx plus c is equal to 0. So what I'm looking to do, I'm looking to get x on its own. So the first thing I can see is we could subtract c from both sides to help get the x terms on one side and everything else on the other side. So let's subtract c from both sides. So ax squared plus bx is equal to minus c. The next step that I'm going to do is to try and get x on its own. Well, to do that, I could either divide everything by a, or I could divide everything by b, and that will get one of our two terms on its own. The method that I'm going to take is to divide both sides by a. So that's going to give us ax squared plus bx all over a. Remember, we must do it to everything, and we must do the same to both sides, is equal to, and we could write this either way. I'm going to write this as the fraction minus c over a. We know this is the same as saying minus c divided by a, so they are indeed the same. So now let's work with this side just to simplify this down slightly. So if we have this division, we can actually split this apart to ax squared over a plus bx over a. And there are a number of theories that relate to divisions, relate to fractions, and how you can combine and separate them. I'm not really going to be going into details of them here. But just trust that this is something we can do. We can, if we have the same denominator on both sides and we're adding or subtracting on the top, we can split that into multiple components. And that allows us to simplify because we can see, well, the a's here are going to cancel. So x squared plus, and I'm going to rewrite this as b over a times x. It's the exact same thing as b times x over a. And that's equal to minus c over a. Fantastic. So this is getting us somewhat closer, but we do need to get rid of this b over a. Now we're going to add a value to both sides, and that's not going to make a huge amount of sense right away. This is the step that I mentioned earlier that appears to come from thin air, but it's actually based on mathematical theories that relate to expanding expressions that are in the form of a plus b squared, or in this case it's actually going to allow us to factorize into this form. Now this all relates to a rather large topic that's known as factorizing quadratic equations. So if you're interested in where this theory comes from and how this theory works and just what I'm doing over these next couple of steps, then if you are interested, go ahead and research that area further. The area is factorizing quadratic equations. So I'm going to add something to both sides, and what I'm going to add to both sides is b squared divided by 4a squared. So we've got x squared plus b over a x plus b squared divided by 4a squared. We must add that to both sides, so that's equal to minus c over a plus b squared over 4a squared. And the reason that we've added this seemingly unusual term to both sides, it doesn't seem to make anything more simple, it seems to make it more complicated, is because now we can put this part of the equation into that form. And the way that factorizes down, I'm simply going to state how it factorizes down, and then to prove to you that this is in fact valid, I'm going to expand it back out and you'll see that we get this value. So I'm going to factorize this down, and it becomes, open parentheses, x plus b over 2a all squared is equal to minus c over a plus b squared over 4a squared. So let me now expand this back out and prove to you that that does indeed equal this part of the equation. So I'm going to expand that out. So we have x plus b over 2a all squared. Well, that's the same as x plus b over 2a times x plus b over 2a, which means we need to multiply x by x, so that's x squared, x by b over 2a, so that's going to be x times b over 2a, so plus x times b over 2a. Then we need to multiply b over 2a by x, so that's plus another x over b, or either times b over 2a. And then finally, we need to multiply these together at b over 2a times b over 2a. That's going to be b squared over 2 times 2 is 4, a times a is a squared. So b squared over 4a squared. Notice we are getting close there. So that's going to become x squared plus, and here I'm going to notice we have two of these. So if we're taking x divided by b over 2a, or x times b over 2a rather, and we're adding two of them, well, imagine this is like having x times b over a and then dividing it again by 2. Well, notice we're taking two of them. So I know this is jumping a few steps, but this is just, again, just trying to prove that this does come from somewhere and it does actually equal the same. It basically means that by having two of these, those 2's cancel out, which is going to give us plus x times b over a plus b squared over 4a squared. If we take a look now, x squared plus b over ax, well that's the same as x times b over a, we've just flipped them around, plus b squared over 4a squared. So b squared over 4a squared. So that does indeed mean that this is equal to that. So what I'm going to do, I'm going to rewrite, not this step right here, I'm going to rewrite that out now and then continue simplifying. So the step that we'd got to was x plus b over 2a all squared is equal to minus c over a plus b squared over 4a squared. So we've kind of got the left-hand side simplified down quite nicely so far. Let's start working with the right-hand side. And as we saw earlier, if we had two divisions, two fractions that shared the same denominator, then they could combine into a single fraction, a single division. Well, I want to do the same thing here, but kind of in reverse. I want to combine both of these into a single division. To do that, I need to get this denominator equal to the same as this denominator, but I'm not allowed to change the overall value of the fraction. So again, we said that if we multiply and then divide by the same number, we're going to cancel each of those out, which means we'd get the same number as we started with back out. So if I was to take minus c over a, and I was to multiply it by 4a, and divide it by 4a, I wouldn't change the value of this fraction in terms of its actual numerical value, but what I would be able to do is if I divided by 4a, I'd actually get a result of divided by 4a squared. That's the same as this guy, and it allows everything to combine together. So x plus b over 2a all squared is equal to minus 4ac divided by 4a squared. I've multiplied the top and the bottom by 4a, and that is given as now 4a squared on the bottom, because 4a times a is 4a squared, plus b squared over 4a squared. Again, along with our theory where we put everything into these parentheses, there are a huge number of theories that relate to fractions and the addition and multiplication and division of the fractions, and there are too many to really get into in depth in this video. So please, if any of these steps don't make sense to you, if you're not sure where this is coming from, then please go ahead and research things such as the addition and subtraction of fractions and understand those theories, or go ahead and research factorizing quadratic equations and the likes. I do apologize if you're not familiar with any of these steps, but obviously there is going to be a certain level of knowledge that is expected, and then everything else builds on that knowledge, and everyone's coming in from different backgrounds, so it's going to be really hard to know just what we need to cover and what we don't need to cover. So we've got it to this point, which allows us now to combine both of these terms. So I'm going to combine these terms together. So x plus b over 2a squared is equal to, and combining these together, we're going to get minus 4ac plus b squared all over 4a squared. Now I'm going to rearrange that slightly, so x plus b over 2a all squared is equal to b squared minus 4ac all over 4a squared. Nice, we're making real nice progress here. So what I need to do now, I'm trying to get x on its own. So I think it's about time to get rid of this square. Now that we've got the right hand side of the equation in a much simpler form than it was previously, if you note, previously we had this minus c over a plus b squared over 4a squared, and now we have this b squared minus 4ac over 4a squared. I'm now going to take the square root of both sides. So the square root of this is obviously going to cancel out as squares, so that it leaves us simply with x plus b over 2a. That's going to be equal to the square root of b squared minus 4ac all over 4a squared. Now there's another theory that we can use here, though I am going to need a new sheet, so let me bring up a new layer. And let me just write that last step out again. So that last step was x plus b over 2a is equal to, that's equal to the square root, and we must remember, of course, that it's actually equal to plus or minus the square root of b squared minus 4ac all over 4a squared. Now there's another theory here that relates to when you're taking the square root of a fraction, and that theory allows us to rewrite this as x plus b over 2a is equal to plus or minus the root of b squared minus 4ac divided by the root of 4a squared. And in this case it's actually just divided by the positive root, because really what we're doing is we're plus or minus here. My apologies if that confused people. We're adding or subtracting the entire square root. Well, this square root can actually be broken down into the square root of the numerator divided by the square root of the denominator, the positive square root in both cases, and then we take the result of that and add and minus, just as we would here, add or minus the result. And in this case, taking the square root of 4a squared, we can actually simplify this down. We can see that a squared, well, the square root of a squared is a, and the square root of 4 is 2. And there's another rule when working with powers that allows us to basically simplify this down. So x plus b over 2a is equal to plus or minus the root of b squared minus 4ac over, and this actually becomes 2a. Now I know, again, this is another step that without the required background knowledge is going to seem like it came from nowhere. Again, just remember in the back of your mind, I want you to see that there was a process that gave us the final equation, the final solution that we're going to get to, but remembering how we got there or being able to do this yourself really isn't important. So if a lot of this seems unusual to you, if a lot of the theories that I'm using to rearrange this do seem unusual because you haven't seen them before, please don't worry. It's really not important how I got there. It's just the fact that I have used a series of steps to get there that is important. So we're adding or subtracting the entire fraction. Well, this is a positive value, so I can actually rewrite this as x plus b over 2a is equal to plus or minus the root b squared minus 4ac, and have that over 2a, and that's not changing the result of the right hand side of the equation. Whew, so we're making some progress. The last thing I'd really need to do is to bring b over 2a over to the right hand side by cancelling that addition with subtraction. So x is equal to plus or minus the root of b squared minus 4ac over 2a minus b over 2a. Notice we have a common denominator. We can combine these fractions together, which gives us x is equal to plus or minus the root of b squared minus 4ac minus b outside of the square over 2a. And this is more commonly written as the form that you will see in pretty much any maths textbook. This is the form of equation for solving a quadratic equation, and that is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So this is the important guy. This right here is the equation that we use, the formula that we use for getting the value or values of x in order to solve an equation in the form ax squared plus bx plus c is equal to 0. Now you don't need to remember this formula. There's no point in remembering formulas for the sake of remembering them. All that's important is you remember that this formula exists, and you remember where you can go to find it, whether that's by searching online and finding a web page that has it, whether that's using your maths textbooks, whether that's referring to these videos. As long as you can remember that it exists, it is out there, and you know how to use it when you need to use it, then that's all you're going to need. You don't actually need to remember this. I mean, sure, it may speed you up 5 minutes, 10 minutes to save you from searching from it, but it's not in any way when you start using these mathematics in a practical situation. It's not like when you're at school and they're going to ask you to remember this for a maths test. I mean, the real world doesn't work like that. Being able to remember all these crazy formulas isn't important. What's important is understanding what they are, how they work, and where you can find them when you need them. So, there's a couple of points I want to talk about. The first was that when we're drawing the curves, we saw we could have two solutions. I'm going to jump back to, I believe it was on this whiteboard. There we go. We saw we could have two solutions if our curve cuts the x-axis twice. We could have one solution if we're sitting on the x-axis, or we may have no solutions if we're floating above the x-axis. So how do I know how many solutions we have using our formula? And once we know that, how do we get those using the formula? Well, notice what we've got here. We have plus or minus a square root. So it seems logical that if we're going to get two solutions possibly, but those two solutions are going to be one of them being plus the square root and one of them being minus the square root. So in the case that b squared minus 4a, so b squared minus 4ac is positive, that is to say it's greater than 0, well, what does this tell us? Well, we know we can get a square root of a positive number, and it's going to be some positive number, and that means we could add it or subtract it, giving us two different solutions. One where we'd take minus b, we'd add the square root of that positive number and divide that by 2a. The other where we take minus b, we subtract the square root of that positive number and we divide that by 2a. So when b squared minus 4ac is greater than 0, that is to say when it's a positive number, then we have 2 points of intersection with our curve and the x-axis, which means we have two solutions. Okay, well, what about the other cases where we have just one solution or 0 solutions? Well, notice if b squared minus 4ac was equal to 0, well, in that case, it doesn't matter whether we add or subtract the square root of 0. In both cases, the square root of 0 is 0. So if we add 0 or we subtract 0, we're going to get the same result. So when b squared minus 4ac is equal to 0, there is only one answer, minus b divided by 2a. So that means when b squared minus 4ac is equal to 0, there's just one solution. If we were to graphically represent that curve, we would see that we are just at the turning point touching our x-axis. Finally, if b squared minus 4ac was less than 0, that is to say that it's negative, well, we can't take the square root of a negative number. Now, okay, I'm going to admit to those of you that are very aware of this, there is a branch of mathematics out there called imaginary numbers, which does allow us to find the square root of a negative number. However, it doesn't apply here. It doesn't affect us for the purpose of solving this equation. And so what I'm going to just generally stipulate is for the purpose of solving this equation, we cannot find the square root of a negative number. That means if b squared minus 4ac is negative, we cannot find the square root of that, and that means we don't have any solutions, which in terms of our curve is a curve that is hovering above or if it was a curve that was flipped over the other way, hovering below the x-axis. That's to say it doesn't intersect the x-axis at any points. Now the really nice thing is, in order to solve for the value of x, we're obviously going to have to calculate b squared minus 4ac anyway. So what we can do is we can calculate b squared minus 4ac first, and given that value we can test to see if we're finding two solutions, one solution, or if there isn't a solution. And once we have that value, if we were programming this formula in, once we calculate that value, we can then determine the action that we need to take to finish the solution. If it's positive, then we take the square root of it and we add that to minus b and divide the result by 2a, and we subtract that from minus b, divide the result by 2a, and that gives us our two solutions. If it's equal to 0, then we simply take minus b over 2a to be our only solution, and if it's less than 0, then we know that we don't have a solution, and so we need to take the appropriate action when we didn't have a solution to our particular equation. Now you also notice we've got a divide here, and as we've been looking at in some videos up until this point, if we're dividing and we're programming a formula that has a division, we need to be careful, of course, that we don't divide by 0. And here there is the possibility of dividing by 0 if a is equal to 0, which of course then makes 2a equal to 0. However, if a is equal to 0, we're not dealing with a quadratic equation. Think about it. If ax squared plus bx plus c is equal to 0, and we've said that a is equal to 0, it's the only time that we would be dividing by 0 is if a is equal to 0, well then that means we have 0x squared plus bx plus c. Well, if we have 0x squared, that disappears. We just have bx plus c equal to 0. This is a linear equation, and we can simply solve this by saying, okay, let's subtract c from both sides. I'm going to actually use this bit over here because I'm running out of whiteboard. So subtract c from both sides. Bx is equal to minus c. Divide both sides by b. Bx is equal to minus c over b. So we could put a test in at the very beginning to check the value of a. If a is equal to 0, then we use this to find a value for x, because we know we're dealing with a linear equation. And if a is not equal to 0, we then use our quadratic formula. We check the value of b squared minus 4ac, and based on that determine if we're finding two solutions, one solution, or if indeed there aren't any solutions. So now that we've seen that formula for solving a quadratic equation, I'd like for you guys to use that formula to find the solutions for some quadratic equations. So I'm going to set some equations, and what I'd like you to do first is evaluate b squared minus 4ac to determine how many solutions does that equation have. And then once you know how many solutions there are, I'd like you to find those solutions. So you are going to need to know this equation to find the solutions, so just make sure you've got a note of that. And I'm going to bring up a new whiteboard, and I'm going to set question 1. The equation I'd like you to find the solution of is 3x squared plus 2x minus 5 is equal to 0. So go ahead and on your own use that equation, use that formula to solve this particular quadratic equation. And once you have a solution, or if you get stuck, unpause the video and I will work through the solution on the whiteboard. Okay, welcome back everyone. So we know our equation, our formula for solving this quadratic equation is x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. So now we can plug numbers into this equation. So we know that a is equal to 3 because it's ax squared. So a is equal to 3. B is equal to 2 because we have ax squared plus bx. And c is equal to minus 5. Now the first thing I want to do is determine how many solutions are there. So what we're going to do is we're going to evaluate b squared minus 4ac. So b squared minus 4ac is equal to, well, b squared is 2 squared minus 4 times 3 times minus 5, which is equal to 4 minus 4 times 3 is 12 times 5 is 60, and we have a negative there, so it's minus 60, so minus 60, which is equal to 4 plus 60, which is 64. So we have a positive value here. That means there are two solutions, and those two solutions are going to be x is equal to minus b, minus 2, plus or minus the root of 64, divided by 2 times a. So 2 times a is 2 times 3. So x is equal to minus 2 plus or minus the root of 64 is 8, so plus or minus 8, divided by 2 times 3 is 6. So that means x is equal to minus 2 plus 8 over 6, or the other solution, x is equal to minus 2 minus 8 over 6. So our two solutions, x is equal to, well, minus 2 plus 8 is going to be 6 over 6. Minus 2 minus 8 is going to be a negative 10 over 6, and we can simplify these down so that x is equal to 1, or x is equal to minus 5 over 3. So these are our two solutions for x. These are the values for x that if we put them into our equation up here, into this equation, we would get 0 as the result. So that's question 1. I'm going to set another question for you guys real quick. So new whiteboard. So question 2. Again, I'd like you to solve this quadratic equation. The quadratic equation is 4x squared plus x plus 10 is equal to 0. In this case, I'd like you again to tell me how many solutions there are and then find those solutions. So go ahead, pause the video and give this a go, and when you come back I'm going to work through the solution. Okay, welcome back everyone. So again, I'm going to note that a here is equal to 4, b is equal to 1, and c is equal to 10 because we have 4x squared plus 1x plus 10. And using that, I'm going to plug them into our equation, which of course is x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. So the first thing, to determine how many solutions do we have, I'm going to evaluate b squared minus 4ac. So b squared minus 4ac is equal to, b squared is 1 squared, didn't really need parentheses there, but oh well, minus 4 times a is 4, times c is 10, 1 squared is 1, minus 4 times 4 is 16, times 10 is 160, 1 minus 160 is minus 159. Ooh, we have a negative number here. That means we have no solutions, and therefore there aren't any solutions to find. So that is actually the end of question 2. Again, because we have a negative number, a negative value for b squared minus 4ac, we can't find the square root of that negative number. That means there are no solutions for x. Okay, let's continue with another question. Question 3. So again, we're looking at a quadratic equation. This equation's x squared plus 5x plus 4 is equal to 0. And again, I'd like you to tell me how many solutions there are. And once you've found those solutions, I'd like you to solve that equation for those solutions. So go ahead and pause the video, and when we come back, I will work through the solution on the whiteboard. Okay, welcome back everyone. So again, let's make note that a is equal to 1, b is equal to 5, and c is equal to 4. In this case, again, we have 1x squared plus 5x plus 4. So a is 1, b is 5, and c is 4. Our equation for solving for x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. And again, to determine how many solutions we have, we need to evaluate b squared minus 4ac. So b squared minus 4ac is equal to, b is 5, so 5 squared, minus 4 times a is 1, c is 4, that's 25, minus 4 times 1 times 4 is 16. That gives us a value of 9 for b squared minus 4ac. Therefore, b squared minus 4ac is positive, and we have two solutions. Those two solutions are x is equal to minus b is minus 5 plus or minus the root of 9 divided by 2 times a. Well, a is 1, so that's just divided by 2 there. So the root of 9 is 3, which means our two solutions are x is equal to minus 5 plus or minus 3 over 2. Therefore, x is equal to minus 5 plus 3 over 2, or minus 5 minus 3 over 2. In the first case, that's x is equal to minus 2 over 2. In the second case, that's x is equal to minus 8 over 2. Both of these simplify, so x is either minus 1 or x is minus 4. So these are our two solutions for x, such that they satisfy the equation x squared plus 5x plus 4 is equal to 0. So just one last question that I'd like to set you guys before I wrap this video up. So let's bring up another layer. Fantastic. Question 4. So again, I'm going to set a quadratic equation. That's 2x squared plus 4x plus 2, in this case, is equal to 0. And I'd like you to tell me how many solutions this equation has, and then find those solutions. So go ahead and pause the video, and when we come back, I'll work through the solution on the whiteboard. Okay, welcome back everyone. So again, the exact same thing that we've done for the last 3 questions. I'm going to take note that a is equal to 2, b is equal to 4, c is equal to 2, because we have 2x squared plus 4x plus 2. And our equation for solving is x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a. Fantastic. So we need to find the value of b squared minus 4ac in order to find how many solutions we have. So b squared minus 4ac is equal to, b is 4, so 4 squared minus 4 times 2 times 2, that's equal to 16, minus 4 times 2 is 8 times 2 is 16. That's equal to 0. Now what did we say when b squared minus 4ac is equal to 0? Well, the root of 0 is 0, therefore plus 0 or minus 0 is going to give us the exact same answer. That means there's only a single solution in this case, where x is equal to minus b divided by 2a. So x is equal to minus b, well, b is 4, so x is equal to minus 4 divided by 2 times a is 2. So x is equal to minus 4 divided by 2 times 2, that's equal to minus 4 over 4, that's equal to minus 1. So the only solution for x is minus 1. That's the only value you could put into x in this equation in order for the equation to be equal to 0. So alright, I really hope by now that you're very, very comfortable using the formula x is equal to minus b plus or minus the root of b squared minus 4ac all over 2a in order to solve an equation, a quadratic equation, in the form of ax squared plus bx plus c is equal to 0. Now don't worry if you still don't really understand quadratic equations. Like I mentioned earlier, there's a huge amount involved with them, and I really have just barely scratched the surface here. And also, don't worry if you didn't follow how we derived this formula, how I got from our quadratic equation of ax squared plus bx plus c to this formula. Really, that's not important. I mean, yes, it is important, obviously it comes from somewhere, but it's not important to remember. It's not really even important to understand. All that really matters is that you know that this formula does indeed come from somewhere. It doesn't just come from thin air, and it was simply taking our equation that we're trying to solve, which is equal to 0, and rearranging that to get x in terms of our other values in that equation. So as long as you know that this equation exists, and you understand how to use this equation to solve a quadratic equation in the form ax squared plus bx plus c is equal to 0, and as long as you know where you can find this equation, because you don't need to worry about remembering it, just know that it's out there and where you can find it, that's all I really want you to take away from this video today. So with that, that is going to conclude this video. I really hope that you benefit from understanding this particular formula and how it works, because it is incredibly useful when you're trying to solve quadratic equations. And like I said, that's going to conclude this video. Thanks a lot, everyone.